Hi everyone, so we are going to tackle in this little video question number 7, which is in problem set out of supplementary worksheet number 4. Okay, so let's get to it. So I'm just going to choose another color here. That's red, violet. Okay, so let's assign oxidation numbers here. So hydrogen, as you know, is +1. Chlorine is -1. 3 times -1. So now this whole thing has to be neutral. And so we have carbon has to be +2. +2 and +1 is +3, and then that balances out that -3. So now we're going to do this one here, 4 times -2, oxygen's -2, and then that's -8. This overall has to have a charge of -1. That gives that +7. Neutral element here, 0. Oh, I missed the hydrogen ion, but it's +1. Already assigned. Oxygen is 2 times -2, -4, +4. Mn +2, -2, 2 times +1. Okay, so now we want to see who's experiencing a change in oxidation state. So we see that carbon is going from +2 to +4, and chlorine is going from -1 to 0. And we notice here that Mn is also changing, +7 to +2. So there's a few things changing here. Not a problem, not to worry. Again, the whole premise behind this balancing is that the number of electrons lost equals the number of electrons gained. So as long as we work with that, it doesn't matter that more than one thing could be oxidized or reduced. Okay, so it doesn't really matter who you start with here. So I'm going to start with, I guess, chlorine. And the chlorine, notice that it's not balanced to start. There are 3 of them here and 2 of them there. So I'm going to do that first of all. So to get that to balance, I would need a 2 there and a 3 here so that there's 6. So now I'm going to figure out the number of electrons. Every chlorine is -1 going to 0. That's 1 electron lost. The oxidation state is becoming more positive. But there are a total of 6 chlorine atoms doing that. And so in that case, we're going to make sure that we have to write 6 here as the number of electrons lost. Okay, so now we can go maybe to carbon. Carbon is going from +2 to +4, so it's experiencing, again, a loss in oxidation, a loss in electrons or an increase in oxidation number. Pre-balancing, there's 2 here carbons, only 1, so we're going to put a 2. So each carbon goes from +2 to +4. That's 2 electrons per carbon times 2 because there's 2 carbons, 4 electrons lost. Okay, we need a reduction, otherwise something would be going wrong because we can't have 2 oxidations or 2 reductions. A redox reaction has at least have 1 oxidation minimum and 1 reduction minimum. Okay, so let's see what happens to the Mn. Mn is +7 to +2, so it's gaining electrons. It's already balanced, so it's 5 electrons for that 1 mole of Mn. Perfect. So now let's make sure that our number of electrons lost equals gained. I have a total of 10 lost here, and I have 5 gained. So that's not balanced, so we're going to need to multiply this by 2 to get 10 electrons gained. And so that 2 becomes the coefficient here in front of MnO4. The 2 becomes the coefficient there in front of Mn. So the last thing we need to balance is our water, and we haven't put a coefficient there, so it might be likely that we need a coefficient there. Okay, so we don't want to touch any of the other numbers or we'll upset our balancing. So let's go ahead and it doesn't really matter who you start with, I guess. Maybe I'll start with oxygen. So there's 4 oxygen over here. I'll need to change that number to get the right number of oxygen. So let's go back on this side. There's 8 here, no oxygen there, so 8. So if this contributes 4, that means I would need a 4 here to get an additional 4 to make 8. And now I see that I have 8 hydrogen on this side. Be careful with this one because there's 2 hydrogen there. And so I simply would need a 6 here to finish up and get 6 plus 2 is 8, balancing that 8 hydrogen on that side. So that's question number, oh, I think I called this question number 4. I apologize. It's question number 7 here on worksheet number 4. All right. Thanks, guys.